Hello friends, सबको नमस्ते. So today in this video we will create the model using a YOLO which can classify the image whether the particular image belongs to the sea, building, street, forest, mountain, etc. Okay, so before that let me explain you. This is some data set which contain three folders, and inside a train folder we have a multiple class names: building, forest, glacier, mountain, sea, and street. You can see it easily. Okay, let me show you the mountain images. It contains 2487 images are present in the mountain. You can say it. And same for the building, forest, glacier, and street. So let's get started to explain the code line by line. I already downloaded my, you can say download or upload my zip file of my dataset in my Google account. So I can download that, you can say the file. Just copy the share link and paste it here. Just keep the some little part, small part of that. Okay. In every video, I explain you how you can connect your Google Drive, or not Google Drive. How can you download your zip file from zip file which is present in your different Google Drive, and you want to upload that Google zip file in a particular Google Drive which is open on different Google account. So just copy and share this. You can watch any video of mine. There I explain each and everything what is happening here. So just run this cell. See, my zip file will get downloaded. Say this is zip file. Now we have to unzip it. For that, just run the cell, and you unzip it, your file will get ready, or you can say your dataset is ready to train. This is your dataset with multiple folder, nature, train, and well, and each folder contain multiple class names. Okay. And Ultralytics is a package through which we can import the YOLO model. Okay. So from Ultralytics import YOLO, and we have to load the pretrained model, and here we are using YOLOv8. And you can see that here for the classification purpose we have a multiple YOLOv8 models like YOLOv8 and S, M, L, and X. The model which we are using is L. It's contained 37.5 million parameters. Okay, so here we go. And after loading it, pretrained model, we have to train that particular model on a custom data set. For that, we have to use model.train. Just give the dataset directory, that is your dataset directory. That epoch will be 10, but here I will just want to train it with 2 epochs because we have a lot of images. Okay, it will take time for training, but I already have a model which is trained on more than 10 epochs. Okay, and you can see that each model is trained on 224 image size. So here the image size will be 224, batch will be 8. Batch 8 here means when during training, when the number of images are divided into the batches. So I want that in each batch 8 images should be present. Okay, now what is the use of this for a name attribute is that when I will run this cell, you will see that a run folder will there. Inside run folder, Glacier folder will be there. Inside the Glacier folder, one folder will be there whose name will be decided by us, and that folder name is this. What is the use of this folder is that inside this folder, wait folder will be there, and inside the wait folder, your best model will be get saved. Now, save will be true. Yes, we want to save the wait file. Save period -1 here means we do not want to save every epoch wait file. We will just want to save the best model. Okay. Patience 20 means always stopping, means after every 20 epoch, it will see that whether the accuracy is increasing or not, or the loss is decreasing or not. Otherwise, if it is not improving or decreasing, it will stop the training there only and save the past model. Validation true. Yes, we have a validation folder, so it's will be true. Okay, now let me run this cell. Okay, this will take time. You can see it. Our training gets started. Here GPU mem is GPU memory which is required during training. Loss is a classification loss here, and here 1736. 1736 here is the number of batches present. So for the 2 epoch also it will take time. Okay. Now you can see this inside a run folder. Run folder is created. Inside the run folder, classifier folder will be there. Wait for it. It will open. It will show. Just refresh it. See, classify folder, the nature dataset, and inside the nature dataset, wait folder is there. But inside the wait folder, nothing will be there because epoch 1 is not completed yet. Okay, now let me uh, let me load the model, which is the best model during training. We have to load that model. After that, we have to keep the test image for directory folder. When we will give it, we have to make the list of all the folder name which is present in that particular directory. Let me show you. So here it will create the list of building, street, glacier, mountain, sea, and street. Okay, now I have to represent subplots for 16 subplots I have to represent. For that, I have to plot 4 rows and 4 columns. So here it is 4 rows and 4 columns. Each figure size will be 16 by 16. Now for IDX in range, so for the plotation of all 16 images, I have to do for loop for the 16 time. Now randomly I have to select the folder name. After getting the folder name, I have to make the list of all the file names present in that particular folder, image file name. Okay, for that I have to make the directory. So here OS path join, first give the test image folder, then the image folder which we have selected randomly. It will generate the directory of the folder with the whether it is building forest English, and OL this directory make the list of all the file name present in a particular directory. Now we have to make the image path directory. For that we have to use OAuth path name. Just keep the test image directory, image folder, and random select the image file name. Here we get the image path. Now after getting the image path, we have to just read the image. Here I am reading the image bit image.open, but I want to it's not compulsory that you have to read CB2 or PIL image, but it's up to you. But here I am using image.open with image path, and here you can either you can pass the image directly after reading it with either with a CPU or a PIL, but or a image path. It is nothing will be happen. You can pass image path or a direct image, nothing will be happen, no error will be there. It's up to you what you will want to use. And what is the use of 0 here? That you can see that we are passing only the one image. So to get the result of the prediction or the prediction made by the model of one image, we can just use the 0 index value. Now let me explain you what is happening here. What is the use of this all thing? First I want to tell you what is the meaning of model dot names. Okay, then I want to print result. Then I want to print yes result props, then the break. Just I want to explanation for you. I think let me check. Oh, it's getting 49%, 50%. So let me explain you what is happening here. So result dot prop dot top one, just one give me the class ID. Okay, after getting the class ID, I have to want to know the which class name is belongs. So class model dot name give me the class name, then the confidence we want. So here I get the confidence using this. Okay, I will explain you what is result dot prop dot top one confidence. Let a training gets completed for the 2 epochs. Then I will explain you what is happening here. Then show image, then the set title, class name, confidence, and just display the image. So while training is going on, let me also download my, or you can say upload my model, which is trained on more than 2 epoch, or you can say more than 10 epoch. So it's completed. Now let me show you the result of the model, which is trained on 2 epochs. Not 2 epochs, let me first explain you what is happening here. See. So this is model dot names, 0 building, one class ID for forest, 2 class ID for glacier, 3 for the mountain, 4 for the sea, and 5 for the street. and this result is start from here. This result start from here and and it till here. Okay, and all the information, result information are stored in this attribute result.probes, and inside the result.probes you will see that it contain data tensor. You can see how many classes we have. We have 6 classes we have. So you can see that in data it contains 6 numerical values, 1, 2, 3, 4, 5, 6. It's represent the probability of the image to which class it belongs to. It represents a similarity, you can say. Okay, so highest similarity, it's belong to this 0.99. Where it is? So highest probability class ID belongs to 1, means this one. You can see 0.99, 0.99 means, or this is top 4 basically it's a confidence for the particular class ID, okay, which have a highest probability. So let me say for I have run this for the first iteration. So the first iteration, the particular image belongs to 0, means the means one class ID belongs to which class names forest, means the first image belongs to forest. Okay, this way we retrieve the information. Now let me comment them all. Now let me show the result of the model which is trained with 2 epochs. See the result: glacier, street, glacier, building, glacier, street, sea, forest, glacier, glacier, sea, forest, glacier, mountain, forest. It's working good. Whether it's training with 2 epochs, also working good. Now let me show you the result of the model which is trained on 10 epochs or more than 10 epochs. I think this is uploading, so let me come back when the uploadation get complete. So the uploadation of the model which is trained on 10 epochs, more than 10 epochs is completed. Now let me show you the result of that. Okay, let me run this cell. Now, oh, what's the problem? Oh, this break. Now let me run it again. You can see the result of the model which is trained on more than 10 epochs. Glacier, street, glacier, building, glacier, street, sea, forest, glacier, glacier, building, forest, glacier, mountain, forest. It means it's working good. Okay, you can download this model and use anywhere you want to use. So I explain each and every line. So please like, share, and subscribe. Thanks to all.